Hello everyone, welcome to this week's MathCast podcast. Today we are joined by an academic scholar and a Math Leap student. Today we are joined by Sahela from Year 13, who will join us to rank the top 10 books that we have both read. Without further ado, let's get started. At number 10, we have The Simpsons and Their Mathematical Secrets by Simon Tsai, and it is on the recommended reading list by Cambridge.
This book is about the TV show, The Simpsons, and towards the end it includes another TV show that's written by the same group. And this book includes all the mathematical background of how the series was made up, and Simon tries to summarize the use of mathematics in 25 years worth of episodes. So it doesn't really dig into the math, rather than it just explains how the people decided to use it within their series.
I agree, and personally I feel like there were those moments where you finally understood what the TV show meant if you would have watched it, but personally I haven't even watched The Simpsons, so this book I couldn't really relate with that much as maybe other readers would have.
I think the reason I've read this book was during COVID. We have seen a lot of clips about The Simpsons and how they relate to real life and stuff. So I was like, okay, let's see how do they get to that point, since they're not philosophers and anything along those lines. They're mostly mathematicians who wrote the book. So it's interesting to see how they were able to predict some of the things that would happen later on just based on math. At number 9 we have Infinite Powers by Stephen Storgates.
This is personally one of the most beautiful and pleasurable books to read. Infinite Powers captivates your interest while explaining mathematics' most extraordinary idea, calculus. It shapes the world we live in today, covering everything from computers, space travel, radios, and even microwaves.
As Hannah mentioned, Storgates tries to explain how rounds were the hardest bit of calculus, how GPS works with 3 signals, and how the FBI uses fingerprints data and changes them to waves to be able to save all the data calculating nearest, and how they could lead to thousands of dimensions. Meanwhile, I believe the book goes into too much history and too many details, and it requires a wider understanding of math from the reader, as it includes some equations that aren't really fully explained. And towards the end, Stephen Storgates makes you question whether AI would be the next thing and whether it would take over, since he mentions that AI and mathematics have been taking a big role in the past centuries.
It actually is really good because it starts off very simple, where anyone who hasn't had calculus before can understand, and then it goes into more depth as the book goes on. At number 8, we have Alex's Adventures in Numberland by Alex Bellos.
Alex's Adventures in Numberlands, I believe, is a very readable book and is exactly what you would want in a very popular science book. It's perfectly readable and understandable. You will enjoy hearing about the Unopo counting system that starts with 20 fingers and toes, into the golden ratio, into iPods, and leading to calculus and algebra.
Alex gives depth and color to the world of mathematics by exploring its history and use in different cultures all around the world. He delves into many topics of math that most of us will never really hear about as students, and this makes math really come alive compared to what we typically experience in school. I highly recommend this book, even for people who don't think that they're a fan of math.
Even if you are a fan of math, I believe that Alex's Adventure in Numberland goes through a lot of details. I have read from the proof of Fermat's last theorem before, and when I reread it in Alex's Adventure in Numberland, it was in more depth and explaining it in much simpler way for other people to understand, for the general public. There are other examples that would boost your knowledge across multiple aspects of math. And for example, if you're interested into speed cubing and other stuff related to that, you might want to be interested into reading that book, because it describes the math behind it and how it developed over the years.
The only drawback I would say to Alex's Adventure in Numberland, it is very heavily packed with a lot of history, and it goes into depth about each time where math has evolved. So if you would like something more related to equations or the math behind it, then maybe this is not the book for you.
As Hannah mentioned, it does cover a lot of history, and if you ever wondered if math was discovered or invented, I think you should read Alex's Adventure in Numberland. As Hannah mentioned, it goes through a lot of history, and Alex goes from the history of the Amazonian Indians, where they started counting on their fingers and toes, to today's world. So I believe you should go through it. So, Coming up at number 7, we have How to Make the World Add Up by Tim Harford.
So this is one of the newer books linked to the stuff that happened in COVID-19, and it gets you thinking about how things such as graphs or personal experiences or your emotions can affect the way that you view data.
Tim Harford works in a newspaper company called the Financial Times in the UK, and he represents how they lie using statistics and data and how we should question them, but meanwhile we should trust some of them. And it presents how people contradict data. Sometimes people refuse to accept the truth, and sometimes people need the statistics to accept the truth. So it makes you question if statistics is a manipulation technique or if it's there to help people around.
It also looks at the psychological side of statistics and how it makes you think, like Sayla said, how it makes you question your emotions or your beliefs or your intuition, where how sometimes data cannot be something that you completely click with. For example, I believe the book talks about linking cigarettes and lung cancer, and about how just because it looks like it doesn't mean that cigarettes are linked with lung cancer, even though in that case it was. And it shows us 10 things to keep in mind when looking at claims that are based on statistics. At number 6, we have How to Not Be Wrong, The Hidden Math of Everyday Life by Jordan Allen Berg.
This book is somewhat similar to what we just discussed, How to Make the World Add Up by Tim Harford. It presents how statistics is used and how people make decisions before seeing the full image. It helps you comprehend information fully and understand what's going on scientifically, statistically, and how it makes a significant change.
Compared to some of the other books, this book is more about how math is used in real life and the power of thinking mathematically, like hinted in the title. And it also discusses ways that math was used throughout history and explains that math is an underrated tool that can be used to solve many problems.
As Hannah mentioned, it describes how math was used in the real world, so it doesn't cover the dull bits of math that you see in everyday's textbook, and it comprehends stuff that aren't like ruled, that you can actually have a thought of.
One example of this is that it mentions how math can help you win the lottery, like how much money you would need to actually win it, and how is this really worth it, and how the money that the lottery companies make is a lot more than you would actually spend on winning the lottery.
And if you're young enough and you read it, you can predict how tall you will be based on your family's history.
It also explains how math can help you meet the right partner, win the lottery, and it's filled with those aha moments when you solve or understand a problem. It also introduces the idea of utils. For example, if you are going to an airport, how early would you actually have to be to guarantee that you wouldn't miss the flight? It just explains so many of these real-life examples that are just so beautiful to read. Personally, I really enjoyed this book, and I would extremely recommend it if you would like these type of examples and the math behind these examples.
At number 5, we have The Man Who Loved Only Numbers by Paul Hoffman.
This is on the recommended reading list by Cambridge, and it is a biography about literally a man who only loved numbers. It talks in depth about who Dr. Edros was, whom he collaborated with, and most importantly, his passion and love for math. He even spent his last few moments working on a math paper, and just to prove how much he loved and was dedicated to math, he actually had a heart attack while solving a math problem.
Edros was born to do math. He's the person who contributed the most to math up to today's world. Edros made Einstein look normal. He wasn't like a psychopath. He had a pure act of kindness towards other people. But when he enjoyed some books or a specific bit of math, he would go and live with that person or that mathematician that he's entrusted about his research until he actually writes a paper about it. So if you were a mathematician in his age, and then you might have had Edros as your guest for a few months or years.
Yeah, it was really nice how he was dedicated to math, and he would stay with the people who he enjoyed to do math with. And just a question that you would probably think about is, did he always have this passion for math, and was he always talented at math? So just something that would answer this question is that at the age of 3, he could multiply 3-digit numbers, and he could do it mentally by the age of 4. He discovered the realm of negative numbers, and from then on, his curiosity for mathematics grew, and his knowledge never quenched.
Edros wasn't really interested into having a family or anything else. He was just interested into purely living for doing math and just math. And that was literally his career. He kept visiting homes, as I mentioned before. He worked up to 19 hours a day, awaking his hosts, and in the early mornings for sufficient results. No one could get in his way. He published over 1,475 academic papers and co-authored 485. I feel like we are literally exposing everything in this book, and we're not giving you a chance to actually read it. But we haven't mentioned anything about Edros' life yet, and I think you should give it a go. As Edros mentioned, every human activity, good or bad, must come to an end, except math.
At number 4, we have Humble Pie by Matt Parker.
Matt Parker is a writer who has a YouTube channel and has appeared in multiple videos by Numberphile, if you're familiar with the channel. If you're interested into math or engineering, you will definitely enjoy this book, as it presents how all of these engineers and mathematicians out there cannot stop having human errors, because it presents all the mistakes that were there in engineering up to today's world.
I completely agree, and I think this book is a great excuse to read about mathematics by reading about the errors in math. And a lot of math books normally just display the successes or the good things about math or the things that make math what it is, but I feel like Matt Parker goes on a completely different way to writing this book. He explains the ways that math has gone wrong and that human errors are unavoidable.
This book, I believe, is one of the books that you would enjoy even reading across a long period of time, because it doesn't have that critical structure that makes you finish a book from back to back. It doesn't really have a plot. It just have trivial knowledge of, oh wow, that happened then, and keeps going through that way for multiple chapters. Each chapter has its own story and has its own plot.
The chapters don't really link that much, so if you don't understand the first part, for example, that doesn't really weaken your understanding of the whole book, so you can just move on. It's extremely enjoyable and very nice, and you also get that aha moment when you understand that something happened at a certain time, and it's extremely enjoyable to read.
One of the main things that interested me in this book, it was during my physics lesson, we were studying about bridges and stuff, and I literally read it the day before in Humble Pie about the wobbly bridge in London, and it explains how it used to go from left to right until it eventually collapsed. So that's literally the entire book. It explains how engineers and mathematicians didn't consider bits and pieces of math and how that affected today's world.
This book was really enjoyable and I highly recommend it. At number 3, we have The Code Book by Simon Tsai.
This is one of the books that are recommended by the Cambridge Reading List. In my opinion, this is a very engaging book, and it has a nice storyline where it goes through the history of cryptography from the ancient Egyptians up to today. It's mostly about cryptography, and I think this is one of the topics that has developed up to today's world, and people are very excited and very interested into it. So if you ever plan into doing cryptocurrency or understanding how it works and what's behind it, I think this is one of the best books to read when you're coming to start, as it goes from the history of Queen Mary of Scots, who was thrown in prison because she thought she got away with her codes, but unfortunately for her, someone was able to decipher them, to modern hackers and how they work. It includes the words and the technology used, such as the Enigma machines, and how Alan Turing was able to use them. He also contributed to the digital world as a mathematician, and it explains how math is literally the basis of all the codes and all the cryptography. Coming up in second place, Significant Figures by Ian Stewart.
This book is a great way to learn about the different mathematicians and what they did. It highlights the key things from each person, including an explanation of their childhood and how this links in with their mathematics. An example is that it mentioned how Gauss was able to sum up all the numbers from 1 to 100, which at a young age, which shows his talent and spark for mathematics at this age.
It also brings mathematics to life, when linking it to different discoveries and inventions. Ian Stewart presents us with 25 of the most important mathematicians, along with the impact of them on math, and their personal stories, explaining the behind the scenes to the title Greatest Mathematicians in the History.
Something I find great is that during this book you realize that their childhoods are so different and they come from such a different background, but the one thing they have in common is mathematics, which is so amazing, and it shows really that it doesn't matter what background you have. It's just as long as you have this passion and talent for math, you can make it as a mathematician.
Stewart's brief but colourful sketches of the life and times of the innovators keeps the pages turning. Besides well-known figures such as Archimedes, Pere de Fermat, Isaac Newton, Alan Turing, and Kurt Gödel. The author also discusses Everest Galileus, an algebraist who discovered a lot of things at a really young age.
Other than them all being interested in math, most of them seem to have manifested aptitude at an early age, but otherwise there are a few shared aspects of class, character, education, or family background. One thing is certain, however, like I said before, they all had a profound love for math.
I think this is a great book for a person who is interested into math.
At number 1, the top recommended book by both of us. So we have Fermat's Lost Theorem by Simon Tsai, and it is also on the recommended reading list by Cambridge.
This is the book that got me into reading maths. It presents the depth of math and how problems that seem very simple took thousands of years to solve, using much more complicated math.
It doesn't actually talk about the complicated math behind it, but rather it looks at the mathematicians themselves, such as Everest Galois, how they were drawn to the problems and how they took math in a different direction using the same problem.
It also presents the story of Andrew Wiles, who I consider one of the most resilient people on earth. And it presents his personal struggles and how he took 6 years to prove Fermat's last theorem, and then disproved it himself, and then reproved it. But then the entire mathematical world celebrated his success.
The story takes you back in time and tells you the history of the mathematicians who came across this challenging and extraordinary problem. I love the storytelling in the book. It really does keep you captivated to continue the book and find out what happens with the proof. And it has such a critical structure linking back to its storytelling, and it presents multiple mathematicians of different centuries and ages who all had the same sense of satisfaction after solving problems independently.
Simon Tsai wrote a lot of books, but I believe this is the best amongst them because it's very simple and it concludes everything and multiple aspects of maths in a very simple way that throughout you will literally understand it if you are actually reading it critically and focusing on what the book is saying. You don't need any background information. All what you need is to understand the words, and it goes flawless from there.
I strongly recommend this book for everyone who is trying to get into math and who wants to just know the history behind arguably the most famous mathematical problem and how it got to be solved by Andrew Wiles. And that's our ranking. Make sure you let us know your opinion on any of these books if you do end up reading them. And if you disagree with any of our rankings, make sure to let us know down in the comments below.